For the first lesson, we will tackle about the Boolean algebra, including its rules, laws, and logic gates. Before we start, we shall define what is Boolean. Boolean is answerable by a yes or a no, or true or false. Then let us define what is Boolean algebra. Boolean algebra is used to analyze and simplify the digital logical circuits. It is also the set of rules used to simplify the given logic expression without changing its functionality. It uses only the binary numbers such as 0 and 1. It is also called as logical algebra. It was invented by George Boole in 1854. Before we proceed to the problems, let us know what are the rules in Boolean algebra. The following are the important rules in Boolean algebra. The first one is that the variable used can have only two values, binary 1 for high and binary 0 for low. The second one is that the complement of a variable is represented by an overbar or an apostrophe. Thus, the complement of a variable b is represented as b with overbar or b with apostrophe. Thus, if b is equals to 0, then b complement is equals to 1. And if b is equals to 1, then b complement is equals to 0. The third one is that the logical OR of the variables is represented by a plus sign between them. For example, read as A or B or C. And lastly, the logical end of two or more variables are represented by writing a dot between them such as A and B and C. But sometimes, the dot may be omitted like A, B, C. The next topic is all about the laws in Boolean algebra. Here are the following laws that are going to be tackled in this video. So let's start with the identity law. Let us consider the variable A. For the first expression, A or 0 is equals to A. So let's see the examples. If A is equals to 0, then 0 or 0, which is equal to 0, so case 1 is true. So let's consider that A is equals to 1, then 1 or 0 is equals to 1, which is again true. And summarizing them in the truth table to get their truth values, we end up with these expressions. As you can see, it comes directly from the definition of OR when the second input is constrained to be 0, while the identity for AND comes directly from its definition when the second input is constrained to be 1.
Second law is the domination law. The formula for this law is P and F is equals to F and P or T is equals to T. In this law, the inputted value is like null and void because the input has no effect to the proposition. Next is the idempotent law. It can be noticed with the formula P and P is equals to P or P is equals to P. It is stated that when you end an input to itself or an input to itself, the answer is same as the inputted value. Fourth law is the double negation. It is known in the formula not P is equals to P. In double negation law, the input always matches the output. Commutative law is the fifth among this set of rules. It matches the formula P and Q is equals to Q and P, and P or Q is equals to Q or P. It is similar to the simple property in mathematics. You will only change its position, but still, the output is the same as the original equation.
The next one is the associative law. You can simply notice this law through the formula given below. Furthermore, the associative law allows the removal of brackets from the expressions and also the regrouping of variables. The seventh law is the distributive law. The formula for this law is P or Q and R is equals to P or Q and P or R. And P and Q or R is equals to P and Q or P and R. Distributive law allows the multiplying or factoring out of an expression.
Eighth is De Morgan's law. It is stated in the formula not P and Q is equals to not P or not Q, and not P or Q is equals to not P and not Q. The De Morgan's law applies the negation to both variables and changes the logical connective from end to or and or to end. The ninth law is the absorption law. The formula for this one is P, and P or Q is equals to P, and P or P and Q is equals to P. The absorption law allows the removal of the unneeded variables in the equation.
The 10th law is the implication law, where P implies Q is equals to not P or Q is its formula. This law turns the first variable implies the second variable into the negation of the first variable, and using the logical connector or disjunction that will be discussed later on.
The contrapositive law. The formula for this is P implies Q is equals to not Q implies not P. It switches the places of the variables, negates each or both variables, and does not change its logical connectives. 12th law is tautology. P or not P equals to T is the formula for this law. We use tautology when both variables are the same and are connected by logical connective OR, and its second variable negated to make it equivalent to true. The 13th law is contradiction. The formula for contradiction is P and not P is equals to F. We use contradiction when both variables are the same and are connected by logical connective and its second variable is negated to make it equivalent to false.
The 14th law is the equivalence law. Its formula is P implies Q and Q implies P is equals to P is biconditional to Q. The equivalence law is used when you have two conditional propositions, P then Q as the first proposition and connected by logical connective and then Q then P as the second proposition to make it equivalent to a biconditional proposition. The last law is the exportation law. Its formula is P and Q implies R is equals to P implies Q implies R. The exportation law allows conditional statements having conjunctive antecedents to be replaced by statements having conditional consequence and vice versa in logical proofs. The next subtopic is about logic gates. Looking back at the definition of Boolean algebra, it is used to model the circuitry of electronic devices, and the computer or other electronic devices are made up of a number of circuits, and these circuits can be designed using the rules of Boolean algebra. There are three basic types of gates, and each gate implements a Boolean operation. The first one is the inverter gate, or also known as the NOT gate, which accepts a value of input of one Boolean variable, then outputs its complement value. The example in NOT gate is if A is equals to 1, then 1 will be inverted to 0. The other one is the OR gate, which takes the value of two or more Boolean variables. If either one of the input is true, then the output is also true. The example in OR gate is if A is equals to 1, then B is equals to 0, then 1 or 0 will be equal to 1. The last basic type of gates is the AND gate, which also takes the value of two or more Boolean variables and only outputs true if there are no occurrences of false in any of the inputted Boolean variables. The example in AND gate is if A is equals to 0 and B is equals to 1, then 0 and 1 will be equal to 0. And that's it, guys, and thank you for watching.